I see. Bonsoir. That's the only word I can speak French. So. Okay, so hello everyone. My name is Marcin, and today I'm going to talk about adding GraphQL layer onto a Django application. Okay, so one word about me. I'm a Python developer and I work at Mirumi Software. This is a company in Poland, in Wrocław. And we build web applications, but specialize in e-commerce. And I'm also a lead developer for the project called Sailor, and I'm also the maintainer of the open source community of the project. You can find me on Twitter and on GitHub under those links. Alright, so quick agenda. First, I'd like to talk about Sailor a little bit to introduce the project. Then we will talk a little bit about architecture of a Django application and what problem this architecture has. And then I'll quickly talk about how we made this migration and what problems we had and what benefits we ended up with. So first I will tell you the story of GraphQL at my company. So we started doing GraphQL in 2016. So that was the first time we saw this library, let's call it. And at that time, me, as a backend developer, I was thinking that this is another new JavaScript thing, because we all know that there is every month new JavaScript thing online, and it was released in the context of React. So the first implementation of GraphQL was in JavaScript, actually, and it was released also with Relay, I suppose. So to me, that looked like a new JavaScript thing. Of course, it isn't. Only JavaScript thing. So we just take a look at that, but we had no use case for GraphQL at that moment. And 1 year later, in 2017, we've built one single application with that. So at that time we used Relay because that was the only available front-end client for GraphQL. And I remember that it was very difficult to use. It took me 2 weeks to figure out how Relay works, so this was very early version of GraphQL. So again, it was over there, GraphQL was really nice, but we again had no use case for that really and were not convinced. And 1 year later, in 2018, things were completely different because you could read on the internet a lot of articles about more and more companies migrating to GraphQL, like GitHub, Medium, I don't know, Netflix. Even Nike recently built their store with GraphQL. And also Facebook was claiming that they've been using GraphQL in production for 3 years. So we thought, okay. And at that time also I remember those whole Apollo tools were released. So we thought that this may be a really good moment to actually use it in our project. And we were starting doing our major refactor in Sailor. So we decided to, okay, let's use GraphQL for everything and just rebuild our front-end applications. And in 2019, so today I'm here talking about GraphQL, and my whole company is so excited about this technology that we are using this in three of our projects already. And those teams that don't use GraphQL, they are actually begging to use this technology. So we are really excited about this. Okay, so what is Sailor? So this is the project that I am working on, and this is basically e-commerce platform. It is open source since the beginning, and as I said, we at Mirumi specialize at e-commerce, and we simply needed a tool to build e-commerce in Python. There was some solutions, but we were not very happy with that, so we built Sailor. And it provides basic e-commerce features such as product catalog, checkout and customer accounts. And we also have management dashboard. This is the screenshot on the right side, which allows you to manage products, orders, customers, permissions, etc. Why it is different than other platforms? So you don't simply install Sailor and use it as it is, because we always encourage people to customize it. So you can take this whole code base and do with it whatever you want. So this is just the starting point, like this is the foundation for your project. So if you don't do anything with it, you have simple e-commerce, but actually you can customize it to many different use cases. Okay, so this is this very simple chart, but it shows the architecture. So how many of you is actually familiar with Django or in Python? Not so many, but yeah. So I will quickly explain how it works. So Django is typical MVC framework. So it works like most of web frameworks, I believe, like Ruby on Rails and a lot of PHP frameworks, which I don't know, but I suppose that they won't work that way. So we have three layers, like models, views, and controllers. And what is very specific about this architecture is that it all sits in single code base. So we basically have huge monolith. And this is also the architecture of Sailor before we change it. So first we have database, then we have a layer of Python code. So this is the models that talk to database and all the business logic. So order management, order processing, product management, this all is implemented in Python. And then we have views and controllers. And in Django, there are HTML templates. And views are simple functions that are callbacks for URLs. So, as you can see also on the screen, we have actually two applications. One is the storefront part and the other is dashboard part. So one is private and the other one is public. So this is how Sailor always looked like. And what are the problems with this architecture? So first, the static HTML views. This is really problematic if you have large management views like this one. So this is a screenshot from our dashboard, and this is used to manage products. So you use this view in order to create new products or update a product, and etc. So the problem with static views is that you have to do a lot of page reloads in order to manage very related stuff. So we have products, we have product types, we have some attributes. There are also categories and collections. This is all related, and in order to manage that, you have to click through, like, I don't know, 10 different views. So this is not the best user experience you would expect from a management dashboard. Actually, I counted how many URLs we have from only product management, and there is like 30 different URLs, so this is a lot. Another thing, we have no JavaScript framework. So you don't have to analyze this code, it just shows how messy JavaScript we used to have in our project. So it's 2019, and we are using this ugly logic to update cart quantity in the storefront. So I don't believe this is the right way to do it in, with the current state of technology we have right now. And also it is very problematic to organize your JavaScript files. And why is that? So as I said before, in Django you have those static templates, right? So if you wanted to use React or Vue or any other JavaScript framework, you would have to initialize it on every page reload. So this is not the way you use those frameworks. So they are meant to use them like single page applications, right? So yeah, we ended up with this mess. So this is not good. And the last thing is actually business needs. So right now, one of the hottest trends in e-commerce is migration to PWA. And if you don't know, PWA stands for Progressive Web App, and this is the way to build a mobile application with JavaScript. And it also provides offline mode, so this is really important for e-commerce because you can browse your product listings offline, and this is very convenient also for development because you have single code base. So everything is written in JavaScript. So you don't need any iOS developers or Android developers. Yeah, and we wanted that, to have that in Sailor, and it turned out that for that we need single page application, and to have single page application we need API. And we had no API in Sailor. Yeah. So why we chose GraphQL actually? So first because when we decided to do this migration a year ago, we already knew that this is very good stack because Facebook is using it And as I said before, many companies are migrating to GraphQL. And also it looked like, very battle tested because of how long it's been used in Facebook. So that was one reason. And another one was the promise of exciting stack. So with the all Apollo client possibilities and with TypeScript, you can have this code generation. And this is really like, I don't know if there were such tools before, but before there was like Redux, state management was not so obvious, and with this stack it seems much better now. So we thought that if you want to build API in 2018, this is the way to go. And also we believed that GraphQL will add business value to our product, because if we are an e-commerce platform and we want to compete with other big players such as Shopify, Magento, or those PHP e-commerce platforms, like most of them provides REST API, but GraphQL is still a new thing. So we thought that, okay, if we add GraphQL, we can be like the first platform who does that. So this was the business value for us. Okay, so what do you do if you are a Python developer and you need to build GraphQL? So you have basically single choice. This is the framework called Graphene, and it's the only tool for GraphQL in Python. And it has 4K stars on GitHub, so it is quite popular. It has bindings for various web frameworks such as Django, Flask. But one problem with that framework is that the maintenance of it is not so good, because there is a lot of open pull requests, a lot of open issues, and actually there is only one maintainer who built this project a few years ago, and right now he is busy with something else, and there is like no people who would drive this this project further. So I'm a little bit afraid of that, about future of the project, but we will see. Right now, this is the only way to go. And in Graphene, you define your API like on this example. So you use Python classes, and later, based on that, you generate your SDL schema. So you cannot write your schema in SDL, like for example in Apollo server. It's like the other way around. Yeah. Alright, so this is the interesting part, because now I'd like to tell you about the migration itself. So we started doing this migration in 2018, in February more or less. And thanks to how Django structures the files within the project, we were able to build API one module by module. So in Django, if you have, for example, products and orders and customers, all of them live in separate module. So we were able to, do that by one and not break the original applications we had. So this is really nice. And at the same time, we started building those single-page applications, because we decided to build new single-page applications for our front-end. And this was a very ambitious plan, because at that moment, I remember that I told my boss, okay, I think that in 5 months or something, we will finish this. And yeah, and 5 months later, we only had beta version of our API. And for this single page application, we had like 30%, because it was so much work that we didn't expect that actually. So the biggest issue was single page application. GraphQL was not that big problem. So in July, we have released beta version. It had about 50 queries and 100 mutations. So this is a fairly large API, I guess. And now, in January, I think that we can consider this API finished, but during the last 6 months, we were still finding some bugs, and we were improving the overall quality of our code base. So if you don't have API, GraphQL API, and you are considering to add it, this is a very long process. So in total, it took us 1 year to build this API in project of, that large project. So this is the architecture we ended up with. So it's quite similar to what we had before, but there is one significant difference. So we added GraphQL on top of this whole Python layer. So right now our Python code base consists only of Python. So this is built in. And what we also did, we have removed those front-end applications to separate apps. So right now they are implemented with TypeScript, Apollo client, and React. So they are completely separate. Yeah, so this is the architecture right now. And I'd like to talk to you about the biggest issues that we had during this migration. So the first issue that was very problematic for me at the beginning was lack of good examples. So because this is still very new thing, and if you are doing this for the first time, and even in Python, there is no good examples of how you should build those mutations, how you should design input for your mutations. So we had to figure it out ourselves, and it was very difficult. And I was looking for some examples online. Right now you can find them, but a year ago it wasn't so easy. And I remember that I used a lot this GitHub API. So I don't know if you have used this API, but it's available on GitHub, and you can log in with your own credentials that you use to log into GitHub. And it has a lot of very good patterns, so I recommend you to check it, because, for example, you can take a look how they structure ordering. So we have some query to fetch pull requests, and ordering is implemented with enums. So this is very nice pattern, and this is one of the small patterns, but there is a lot of similar ones, like also limiting the pagination or requiring the pagination. So we have to provide always first and number of actual items you want to fetch. So there is a lot of very nice patterns in this API, and I use that a lot at the beginning. Another thing is also about designing mutations, and as I said before, we had about 100 mutations in this API. So most of them are pretty similar, because if you have any project and you have about 30 models and you want to provide API to cover those models, most of the operations are like creating, updating, deleting stuff. So this is basically the same. So if you build 10 mutations, you already see that they all look the same. So this was also problematic, because I thought, okay, if we did something wrong in those 10 mutations, we have to fix all of them, and we are repeating ourselves. So in Django, we are able to develop this little tool that we call model mutations. It is actually quite interesting, because the previous talk was also about generating mutations. So I think that this is an interesting pattern that in different frameworks we are thinking about the same patterns. So maybe eventually frameworks will implement that. I don't know. So imagine that you have to build those three mutations, like customer create, customer delete, or customer update. So they are pretty similar, and you also have this user model. This is your database model. So we built this little tool called model mutation, and in order to use that, you have to provide those two things. So first you provide your user model, and then you provide the mutation input. So mutation input tells what data you should provide to mutation in order to use it. So for all those mutations, the steps are the same. So first you have to clean the input. So this is like the initial processing of that data. So for example, if this input contains some ID, like GraphQL ID, this base 64 encoded ID, in this first step we could actually decode that ID and fetch our object from database. In the second step, we are able to construct model instance. So in this mutation, I know what model I need to construct. It will be the user model, because I've provided it before. So either I initialize empty user, or I fetch this user from database. And in the third step, I can pass this data incoming from mutation into this new instance and validate it. So if, for example, user has required email, this is a good place to run this validation. And fourth thing, if everything was alright before, then I can save this model to database. So With this little tool, we were able to quickly build those mutations which are mostly the same. And another issue is also about mutations actually, and it's about how to design the input of the mutation. So you can consider those two examples. So here we have mutation to update checkout. Checkout is the object that holds all the data that you need in order to create an order in your shop. So this is the user, those are the products that the user is buying, those are addresses, etc. So either you can have one big mutation to update all of those fields, or you can have smaller mutations. So actually this is the better pattern, but also we didn't know that at the beginning. So actually these examples are taken from an article by a GitHub developer. Here is the link to that article, and this is very well explained there. So I remember that we had problems with that because we didn't know simply what is the best pattern. So after building this API, there are still some unresolved issues that we have. And this is, for example, quite important for me, this one, is about generating documentation, because documentation is very important part of your product, especially if it is open source. And one of the coolest things about GraphQL is that documentation is built in the schema, right? So you can use Playground, you can use GraphQL, and you can browse this documentation within that. But when I was using this GitHub API, it has very good documentation. So all the objects that you have in API are described over there. So we can just, look at it, quickly find where each object is used. It is very convenient. So I'd like to have such documentation in my project, but I don't want to write everything twice. I already have the description in my code because they are available in the Playground, right? So ideally, I would like to have some tool that would export those descriptions out of my code into some kind of document. And I don't know if there are such tools. I am currently looking for one. And that would be great ability to have in GraphQL. Another issue that we have is access to private and public fields, because as I said before, we have this private dashboard, and dashboard needs some private fields like that customers shouldn't see, and currently our API exposes all of them. So this is problematic because everyone can see the fields that are in your schema. They cannot use it because we have some access restrictions, but still they can see it. So I don't think this is a good pattern, and probably the best idea would be to have two APIs, private API and public API, but this is currently, we are not able to do that with our framework. So this is limitation of Graphene because it allows us to define types, like you can have single type for single model, and I cannot define two types, like one private product and public product, and have them both in my schema. So this is maybe a limitation of our framework, but still we have to somehow deal with this problem in the future. And last thing is query complexity. So maybe in the future frameworks will have that built in, but currently we would have to implement it manually. So it's about the shape of query that your API user can actually fetch. So if you have a malicious user, they could create very big query, like very nested one, and that would be very expensive to resolve. So in order to avoid that, we could implement query complexity counting, and based on that we can limit those codes. So some APIs already have that, like for example, I think Shopify has that, I'm not sure about GitHub, but they somehow implement that, but it's still not common. I don't know how it looks like in JavaScript. At least in Python, this is still an unresolved issue. So we came to the end almost, and this is the summary for this transition. So at first we had this problem with static HTML views. So we no longer have this problem because we migrated our front-end applications to single page. It was impossible to integrate JavaScript frameworks, but right now we are using the newest possible stack, I would say. So we have TypeScript, we have React, and we have also Apollo client. Um, as a result of this migration, we have also satisfied our business needs because our project is open source. So the only measure for us to tell if it's popular or not are the GitHub stars. And actually people like what we are doing because we saw huge growth on GitHub since we have started doing this API and migration to single page. So that makes us really happy. And actually, currently we are the top e-commerce written in Python. So yeah, this is really great. And we believe that a lot of those benefits were actually driven by GraphQL. So when I was doing this presentation, I came to this conclusion accidentally, and I think that this is the best summary of this talk. So I believe that right now GraphQL, because this is kind of hype right now for GraphQL, but it really drives your product, and it's also like driving force for your development, because developers are really satisfied when they're using this stack. So this is quite interesting. Alright, so if you are interested in actually checking out, there is a public demo. I was thinking about showing it to you, but I don't know if you have time for that. Basically, this is the demo storefront, so you can browse the products and see how Sailor works. And there is also demo for GraphQL, so this is wrong link actually. But if you go to this one, and this link is at the bottom, so you will find it. And you can browse the playground, you can see what this API can do. So if you ever needed e-commerce API, you might be interested in checking that out. And that's it. I hope you enjoyed this talk, and if you have some questions, I'll be happy to answer.